Thanks for watching new tutorials. Today we are going to discuss about data science. Data science is all about data, probability of a given data point, and also understanding how data looks at a given point. With the above stated, wanted to share about the few libraries which Python provides. So NumPy, SciPy, and Matplotlib. So NumPy is mainly about the array matrix operations, and it works hand in hand with pandas. SciPy is more related with linear algebra. Then Matplotlib is more about the plotting. With that stated, you can download individual libraries, but my preference, I went with Anaconda, the distribution, where you don't need to download the individual libraries, rather everything is pre-packaged with Anaconda. I'm not going to explain about the distribution here in this tutorial. Try to search for Anaconda and then you can download it. Once Anaconda is downloaded, you can launch the Anaconda and then open the Jupyter Lab. Jupyter Lab opens in the browser itself. So once I am here, again within data science there are two categories. One is the fixed outcome data and the continuous data. So there are two distinct categories. When we say fixed outcome, when you roll a dice or when you toss a coin, you have fixed outputs like head or tails, or if it's a dice, then you have probability of getting 1 to 6. You don't get a continuous series of digits or numbers which have floatings. So let's take example of continuous. If you talk about temperature, there is no fixed outcome. It can be 68.5, 98.6. So it's a continuous. So we will look at both the dimensions, one, how to deal with the fixed data sets, how to deal with the continuous variables. So I started with the fixed data sets. So I just was coding the example for the fixed data sets. I was taking an example of the dice here. So as I stated, for data related, I use NumPy. I imported that. For the plotting, I used the Matplotlib. Okay. Within the Matplotlib, I'm using the PyLab. So once that is done, considering I want only the fixed outcomes, I'm using the randint function within random, which generates only the integers, not the floating values. So within NumPy, I am calling the random and then randint for generating the integer values. The lowest value I'm asking is 1 and up to the maximum value is 7. So it won't include the 7, but until 7. So 1 to 6 numbers will be output. I'm asking 100 iterations, throw the dice 100 times and see the outcomes. So the dice was thrown 100 times here. So first time is 3, second time is 3, third time is 4, so on. So I just printed the X to show you how the list came up. Then I was plotting on the bar, because if you are going with the continuous, then histogram or the normal distribution makes sense. But considering you are going with the fixed outcomes, where the x-axis is not continuous, like here, the x-axis is more about the fixed outcomes. I don't need to worry about histograms or the normal distribution, but just go with the bar chart. So I have plotted on the bar chart. X is nothing but 1 through 6, which is laid down here. and range and the count of each number is laid down as a y-axis, how many times it has happened. So I'm showing the plot here. So with that stated, let's move on to the continuous variables. We'll go through histogram as a starting point. I don't need scipher now, so I'm going to import matplotlib dot as bmt. Then I'm going to say so I want continuous numbers now. So let's go with the temperatures, right? So I'm defining np dot random dot normal here, normal distribution, which means I'm saying, let's say I'm living in Texas, so I will say 70 degrees is normal, and during winters it can go standard distribution of 20, so it can either fall to 50 or it can go maximum of 90, so I'm saying 70, or let's make it 25, so it can be 55 to 95 most of the times. Then I want 1000 of these to be generated. With that stated, I will say plt dot histogram. I'm going to have 50 bins of these. plt dot show. Then I will run it. So as you can see, it's a normal distribution here. So this is a histogram. It's a continuous. It's not like on the above where it's a fixed number. Rather, we are going with the decimal numbers as well in between. I did not print this X, but let me show you what it prints. It will provide the in-between values as well. So I'm doing print of X here. Print of X. As you can see, so 70 is the number. I am asking either give me from 45 to 95. This 25 is a standard deviation. So 70 is kind of mean for me, and I am asking 1000 numbers to be generated that way. That's the normal distribution. So it's not uniform distribution again, it's normal distribution. As the number of data points reduce, the skewness increases. So I'm asking to generate between 45 and 95, 1000 data points with normal distribution. So I printed to show it's a continuous numbers, and I plotted and it shows this way. So you can see the 1000 numbers were generated list, and the plot was, the normal distribution plot was there. So this doesn't tell me what is the y-axis, what is the x-axis, which is not good, right? So let me show you how we can improve on that. Copying the same thing here. Now we will say plot dot x label. I can say temperature. I can say plot dot y label, number of days. Now once I do it, I run it again. You can see it shows the temperature. So again, just wanted to explain this function here. So when I say 70, 25 is the standard deviation, what I'm saying is 70 is my mean, and what I'm asking is give me the standard deviation of 25 minus or 25 plus. So 68% of all my data points fall within the plus or minus 25 of 70. It's not that all my data points will be coming within this plus or minus 25, but 68% of my data points will fall in this one. So that's the standard deviation definition by definition. So with that stated, I will show you what the mean is for this one. Let's not assume that when you have normal distribution the mean is exactly 70, because we are going with a limited set of 1000. There will be certainly skewness. So let's see what the mean, so I will say x np dot mean x. I wanted to see np dot, what else can I say in this one? I can say median. Anyway, we know standard deviation, so I'm not running it again. Okay, I did not print it. Let me print it again. I copy it. I did not do the print here. Print. So as you can see, the mean and median are very close, 69.4. Though we asked a mean is average, median, I mean, I'm not going through definitions now, but median is more about out of the 1000. I'm going to pick the middle one. It's not average, but rather removing all the outcomes of on the left hand side and the right hand side, you get the median, which is the center point. If it's odd, if it's even, you take the two center points and do the average. That's the median. So median will give you the true picture whenever there is skewness. Mean will get skewed if there are too much of variation on the right hand side, which is left skewed, or too much on the variation on the left hand side, which is right skewed. Then the mean will get skewed with it, but the median won't. So we try to print both of them so we know. So what we can do to show the skewness in this example, we'll play a trick here. Now we wanted to create some skewness to show you what a skewness mean. So what I was doing is I'm creating a new variable called y, and I have appended a to the one-dimensional array more of 1000 numbers. So automatically I'm creating a left skewness here. So I was doing a histogram with y and 50 bins. So now as you can see, The mean will be more because I'm doing an average with left skewness. So you can see the mean has increased to 74, whereas median still stayed at 70. As you can see, this explains mean is not a very good idea whenever the salary averages are being shared for a given population. You have a lot of 1% population who has a lot of wealth, and they cause the skewness to be showing up, which causes to show that the certain population has more than 150,000 average, which might not be really true. If you show with median, then you know really what's the real salary or real salary for a given population. Mean with standard deviation again helps to show you that there is a lot of standard deviation. Either going with mean with standard deviation or median will help in this case. With that stated, let's try to see the program how we can enhance still. So we have taken X label, Y label until now. So we can even change the X limit and the Y limits as well. So what we can do is plt.x lim, I can say X lim, I can say 0 to 2000. I was increasing this, so if I run it, as you can see, the X limit went to 2000. Similarly, I can change how I want the graph to be. I can even say I'm not that much interested in see there is a lot of gap between 250 to 1000. I'm not that much interested in seeing that, so I'm interested more from 0 to 250 and then 2000, right? So I can really say until now we have seen the x-axis how it was set from 0 to 1000, but we can actually set the actual ticks, so that way I know that there is no data points between 250 to 1000, so I have particularly stated give me only the ticks which are from 0 to 250 and then the 1000. So how I do that is, it's not on the plot but rather on the axis. Set ticks, what ticks I want I can keep, and apart from that I can set the grid so it's more clear as well. So I set the grid as well. So apart from this, doing the legend and the other things, we have until now we have seen histogram and we have seen the bar chart. Apart from this, within the continuous variables we have an option to go for from scipy.stats import norm. We can do the normal distribution, so we can arrange function, and I will say 70 to 150. This is a minimum, this is a maximum value, and I will say 1 is the increment here. Considering we are not appending anything, the ticks, I leave it here, and the grid is okay. The legend, I'm not that much interested. Here I will say plot x comma norm dot, this is density function, probability density function of x. I can run this. It's still processing. So it is still like a histogram where you are doing the continuous variable, but just we are using the SciPy way, using the normal distribution norm.pdf function. So let me show you a proper, it's a straight line right now. So from 0 to 150. Now what I will do is I wanted to make 50 as median, 70 to 150. So it makes sense to use 70, 700 probably, or 110 is a median with 20 is a standard deviation. So as you can see, that what we have done here is it's a normal distribution. What we have done is a range function will have a lower value of 70 and higher value of 150, with 1 being the increment here. So it generated 70 to 150 values. So I'm using normal dot the probability distribution function, with 110 being the mean and 20 being the standard deviation. So 110, you can see the peak here. So that concludes the basic data science modules. We'll discuss more about in-depth advanced data modules in the upcoming chapters. Thanks for watching Nook Tutorials. Thanks for watching Nook Tutorials.